Okay, so hello everyone, this is Akshay here, and let us continue with today's streak of our GFG POTD problem of the day. Today's question name is check for balance sheet. So, although it's an easy category question, but आप ध्यान से सुनना यार, इसमें हम बहुत ही अच्छे तरीके से इसको solve करेंगे. Whatever we have done in the past of our GFG POTD, that will definitely be beneficial for this question, right? ठीक है. So given a binary tree, find its height. Find if it is height balanced or not. So what is the definition of height balanced? So a height balanced is difference between the height of the left and right subtrees, right? Is not more than 1 for all the nodes of the tree. Similarly for this case, तो ठीक है, हम क्या करते हैं, सबसे पहले इनपुट एंड आउटपुट पे चलते हैं. तो अगर आप देखो तो पहले इसके लिए देखते हैं. पहले हम समझते हैं इनपुट एंड आउटपुट, देन आई विल गिव यू सम होमवर्क टू डू इफ यू हैव नॉट डन इट. So for 130, 110, 39 and 5, so what we will do, we will mark the differences of the height of the, for all the nodes, for the differences of the height of left subtree and the right subtree. So if we come at 5, what is the length of the left subtree? It's 0, right? And what is the length of right subtree? It's 0. So 0 minus 0 will definitely be 0. Similarly for 10, the length of left subtree is 1, the height, or let's say, and the right subtree is 0. So 1 minus 0 will give you 1. Similarly for 1, what is the height for the left subtree? It is 2. 10 and 5, there are 2 nodes, right? So in the path there are 2 nodes, it would be height be 2. And what's the right subtree? There's just 1 node, so 2 minus 1 will give you as 1. Similarly for 39, you can clearly see there are no children, so height would be 0, right? The difference of height of left subtree minus RST would be 0. Now for each and every node, the height is always less than equals to 1. So if that's the case, then definitely we can say it's balanced and we need to return the output 1. Now please pause this video here, try to mention the heights of these two test cases, and then resume the video again to match your answer. Okay, so as you can see, for the second test case, I have mentioned the heights. I hope you're able to figure it out, and the answer is 0, because one of the root node here, or let's say one of the node of the tree, was pointing the value of differences of LST minus RST height is equal to greater than 1. That is why it is not a balanced tree. Similarly for the third case, I have mentioned the heights, and that is why none of the values are greater than 1. So that is why it is a balanced tree, right? Now the prerequisite to do this question. So what are we constantly doing for this problem? We are definitely calculating the height of the RST and the LS tree. RST here is right subtree, LST here is left subtree. So prerequisite for you is that you need to know that how to find the height of a binary tree. So we have covered this problem in day 34 as well, if you remember. So one homework for you, I will not repeat it again. So this is the day 344. I mentioned you all the dry runs, all the pseudocode, right? So this is the pseudocode we would be taking help in the today's problem, and we'll be doing some manipulation in that, right? Again, this question is also asked in Leetcode as 110, I guess, right? So the same code would be running here as well. Once you're done the GFG question, we'll move back to the Leetcode as well. ठीक है. तो अगर आपने अब अपनी वीडियो पॉज करके, या फिर आपको पहले से पता था कि हाइट ऑफ बाइनरी कैसे निकालते हैं, वेल एंड गुड. तो ये इसका सूडो कोड है यार, हाइट ऑफ बाइनरी निकालने का. ठीक है, हम इसी में कुछ मैनिपुलेशन करेंगे, एंड वी विल सी दैट हाउ द कोड विल वर्क फॉर द बैलेंस ट्री और नॉट, बिकॉज डेफिनेटली वी आर ऑलवेज कैलकुलेटिंग द हाइट, राइट? सो हाइट तो हमें लिखना ही पड़ेगा. तो हम देखते हैं उसमें क्या मैनिपुलेशन किया जा सकता है. सो आई गेस दिस कोड इज वेरी क्लियर दैट वी आर फर्स्ट रिकर्सिवली गोइंग इन द लेफ्ट, देन द राइट, एंड वी आर फाइनली रिटर्निंग द 1 प्लस मैक्स ऑफ LST प्लस RST. आप इसका ड्राई रन वीडियो में देख लेना, मैं नहीं समझाऊंगा, अगेन टाइम वेस्ट होगा, राइट? लेट अस प्रोसीड अहेड. ठीक है, तो लेट अस से हम कोई एग्जांपल लेते हैं यहाँ पे. हम कोई एक एग्जांपल लेते हैं यहाँ पे. लेट्स से 1, राइट? 1 की लेफ्ट चाइल्ड है 10, 10 का लेफ्ट चाइल्ड है 5, and then it is a leaf node, let's say pointing it as null and null, right? And what else? And let us mark this as 39. ठीक है, if root is equals to return 0, and then we are going recursively to the left, right? So first of all, what will happen? I will be at root node, I will recursively go to left, I will go to left, and I'll again go to left, and I will see it's null. So null, it say return 0. So I'll again it will return 0 from here, and from here it will return again 0, right? Now what we need to do is, before returning 1 plus max of LST comma RST for its parent, what we need to do is we need to check the difference of LST and the RST should be less than equals to 1. So we will write some pseudocode here. Let me write that, and then we'll resume back again. Okay, I have mentioned that extra case. So what is the case? That we are calculating at every point of time, we'll calculating the ABS value of LST and RST. So it is 0 minus 0. ABS will be getting as 0, right? So this is definitely not a problem. It is not greater than 1, right? So we'll not go into this if case. So why return minus 1? I'll explain you, right? So it will not go into this case, and again it will return 1 plus max of LST of RST. ठीक है, तो LST का 0 था, RST 0 था, तो इसमें हम करना है return max of 0 comma 0, it will return 1. Now the call has been transferred to this parent of 5, that is 10 here, it will go, it will call its right children, and it will say it's null. Okay, so it will return 0. Again the calculation will happen, that is the ABS of 1 minus 0, and it will give you as 1. So there is no problem, but because the height difference is not greater than 1, right? So again the parent goes call back, and we need to return the height for this subtree, that is maximum of 1 comma 0 from the RST and LST, and plus 1, that is it will return 2. I have written 2 here, right? And for now let's just assume that this node was not there. This node was not there, let us assume that, right? So 2, right? Again the parent call goes back to this one, and the right children is null, so it will return again 0. And now for this thing, what is the height difference? That is ABS of 2 minus 0, which is 2. So that means height difference is greater than 1. The height difference is greater than 1. So what it will return? It will return minus 1, right? Okay, it will return minus 1. So in the main function, where our actual program is there, we will just return the function of root, right? And if it is equals to what, minus 1, then I'll just check if not equals to minus 1, right? यहाँ पे हो जाएगा, equals to minus 1 है तो क्या हो जाएगा हमारा, तो false return हो जाएगा. And if it is if it is not equals to minus 1, then it will be returning true, right? Correct. ठीक है. Okay. So here in this case, the whole output is returning as minus 1. So that means our what do we say? The overall output using this main line would be false, and you can clearly see that this is not a balanced tree, right? Okay. Now let us take a different case where we can see that what are the more changes we need to do in the code, right? तो हम ट्री के कोड को ऐसे लिखते हैं यार, छोटे छोटे टेस्ट केस लिए ड्राइन करके देखते हैं, एंड यू कैन सी दैट व्हाट आर द अदर थिंग्स वी नीड टू ऐड इन द कोड टू मेक इट वर्क, राइट? तो हम एक और टेस्ट केस लेते हैं. अब इस टाइम हम लेंगे 3 5 and what do we else, let's say 3, and let's say we have another thing as 2, right? And this is null, and this is null again, and what, this is null again, right? Okay. So first what will happen, it will start from the root node, it will go to its left, it will again go to its left, it will again go to its left, and then after 2 you will get null, so it will return 0 from here, it will null again, so it will return 0 from here, and overall there is no problem. The absolute difference of LST and RST is 0, so it will return 1 from here, correct? It will return 1. So I hope that's visible. Again from the right, it will go to the right hand side, it is 0 again, so there is no problem. Again the absolute difference of 1 minus 0 is again 1, which is not greater than 1, so again it will return the height, that is maximum of 1 comma 0 plus 1, that is 2. Again now it will go to the left hand side, and what is the value here? It's null, so if it is null, what we return? 0 here, right? Okay, so that means now here the LHT and RST is actually 2 minus 0 is, which is equals to 2, which is now greater than 1. So we are returning minus 1 here for this case, right? What will happen after this call? After this call, it will again go back to its parent, right? And it will again see that LHT value, what we did, that once the EBS value is greater than 1, we returned minus 1. So LHT is now equals to minus 1. That means हम यहाँ पे एक स्मार्ट वर्क कर रहे हैं यार. अगर किसी भी पर्टिकुलर नोड पे हमें पता चलता है कि वो अनबैलेंस्ड है, राइट, तो हमें बाकी नोड्स के लिए चेक करने की जरूरत ही नहीं है. We do not need to check it further, right? And that is the reason we are doing a smart work here of returning minus 1. So what are the changes we need to do? So before proceeding ahead for the next recursive call, you will check here that if LHT is equals to minus 1, right, then and there you need to stop your function and you just say return minus 1, that the whole entire tree is now what to say, not balanced, right? Similarly for LST, the case which I have just showed you, it is we can see यहाँ पे LHT minus 1, right? So similarly ऐसा case होता है जहाँ पे LST minus 1, right? So I'm not showing you that case, but definitely that is very understandable. So I will just again write here, if LST equals to minus 1, I will just say return minus 1 again, right? So this would be your entire code, I guess. So this would be your entire code for checking if a particular tree is balanced or not, right? तो इसका रिकर्सिव कॉल कंप्लीट कर लेते हैं. तो देखो 3 पे आए, हमने देखा LST की वैल्यू क्या -1 आ रही है, तो हम यहाँ से डायरेक्ट कह देंगे कि रिटर्न -1, राइट? हम यहाँ से आगे फंक्शन ले ही नहीं जाएंगे क्योंकि हमने ऑलरेडी यहाँ पे रिटर्न कर रखा है, तो ये फंक्शन एग्जीक्यूट, आगे की लाइंस जो होंगी वो एग्जीक्यूट नहीं होगी। क्योंकि अगर आप जब भी कोई फंक्शन लिखते हो राइट, कोई लाइन्स ऑफ कोड लिखते हो और जब वहाँ पे रिटर्न लिखते हो राइट, तो इसके आगे कोई भी कोड लिख दो काम नहीं करेगा राइट। रिटर्न मतलब रिटर्न, यहाँ से खत्म कहानी। ओके, और इस 3 के बाद कोई पेरेंट रिकर्सिव कॉल बची भी नहीं है करेक्ट। अगर बचती भी होती तो उसके लिए हम हमेशा -1 रिटर्न करते हैं, एंड दैट इज वी हैव आंसर एज -1। ठीक है यार, तो आई होप आई हैव ट्राइड माय बेस्ट टू अंडरस्टैंड, टू गिव यू अ वेरी understandable approach. We started from scratch and then we have completed a pseudo code. तो आप एक काम करो, now again you need to pause this video here for 2 to 3 minutes. आप क्या कर सकते हो कि आप वो केस के लिए ड्राइंग करो जहाँ पे RST equals to -1 हो रहा है, and definitely, और if else, और नहीं तो आप एक दो केस के लिए और ड्राइंग करो खुद से without looking at the blackboard, and then we have a very good understanding, very fine understanding that how are we actually converting the exact height code to, and with some manipulation to check if the tree is balanced or not. ठीक है, pause this video here and then come back again on the compiler. Great, so I hope you are able to figure this out, that how the pseudocode is working as of now. So let us see the code. The same thing which I have done here is, we have, instead of making a fun, we have given a very conventional name, that is check balance, right? So the base case return is same as it is. This statement is as it is, that is returning the height of the current subtree. Now we were calling for the left, we are calling for the right, and we know why we have used this condition, because if any point of time our left subtree is unbalanced, so the whole tree is unbalanced, right? Similarly for RST we have handled it, and after doing the recursive call we are checking each and every time that if the height difference should be, the EBS values should be not greater than 1. If it is greater than 1, then definitely the tree is unbalanced. Let us now hit the submit button. While it is submitting, let us analyze the time complexity. So while we were doing the dry run, we saw that we are visiting each and every node once, right? Not once, exactly thrice, right? हमने एक बार हम उस जैसे कि हम पहले इस पे आए 2 पे आए, right? And then we visit its children, left children, then again we come back to the parent call, and then we visit right children, again come back to the parent call. So it would be exactly thrice. Again 3 n, including the constants, it will be O of n. And what is the space complexity for this problem? Again the space complexity will be O of height of the tree, because maximum recursive calls क्या हो सकते हैं कि हमारे पास क्या हो सकता है, रिकर्जन का यूज करने का क्या मतलब है कि दैट वी आर यूजिंग अ रिकर्सिव स्टैक। हमारे पास अगर कोई स्क्यूड ट्री ऐसा 1 3 4 and 5, तो सबसे पहले 1 जाएगा रिकर्सिव स्टैक में, देन 2, देन 3 एंड 4। 4 का जब ये लीफ नोड हो जाएगा तो यहाँ से रिटर्न होना शुरू होगा, राइट? So that's the very basic thing. So that is why O of height of the tree would be the time complexity. Let us switch back to the C++ code again. So that is the C++ code is the same as we have done in Java and in the dry run. So I'm just clicking the submit button here. We will get back to the Leetcode question now. Okay, so there's some problem. Let me check what are the braces if they're missing. Okay, there was one line mistyped. Okay, great. So that's the C++ code. Again, we have done the summation. Let us switch back to the Leetcode question. That is 110. So that's the same code running in Java here. So let me just show it to you. Let me just scroll it down. So as you can see, it's the same code. No need to give a walkthrough again. And that is it. And we have a submission here. Let me switch back to the submission tab. Great. As you can see, it has been accepted. And yes, we have done this question. Let us meet again in the tomorrow's streak of our GFG POTD. Until then, keep learning, keep growing. Bye bye, and take care, guys.